Why does op-amp input, offset voltage matter in analog circuits? Have you ever wondered why a tiny voltage can make such a big difference in analog circuits? Let's talk about input offset voltage in operational amplifiers and why it is important. The input offset voltage is the small differential direct current voltage that needs to be applied between the input terminals of an operational amplifier to make the output voltage zero. This might sound simple, but it has real implications in the world of electronics. In practical analog circuits, if the input offset voltage is present, the output can be non-zero even when the input signals are the same. This can lead to errors in signal amplification, measurement, and processing. For example, in precision applications, even a small error can throw off the entire system. The input offset voltage usually comes from mismatches in the internal transistor pairs of the operational amplifier. In general-purpose operational amplifiers, this offset voltage can be a few millivolts, while in precision devices, it can be as low as microvolts. This difference matters because the output voltage is the amplified difference of the input voltages multiplied by the operational amplifier's gain. So, even a small input offset voltage can be amplified significantly, leading to substantial output errors. This is especially critical in circuits like instrumentation amplifiers and sensor signal conditioning, where accuracy is key. If the input offset voltage is not managed, it can lead to incorrect readings and unreliable data. Additionally, the input offset voltage can change with temperature and as the device ages, which can cause further variations over time. Designers often have to consider this offset when creating circuits. They might choose low-offset operational amplifiers or use offset nulling pins to adjust for this voltage. Calibration techniques can also help in managing the impact of input offset voltage. It is also worth noting that input bias currents and input offset currents can create additional voltage offsets when they flow through source or feedback impedances. However, these effects are distinct from the input offset voltage itself. Understanding input offset voltage is essential for anyone working with operational amplifiers in analog circuits. It directly affects the accuracy and reliability of the systems we design. By managing this small but significant parameter, engineers can ensure that their analog circuits perform as intended.